Well, my dad flew into town and we're going to work on a project together. I'd like to say it's something new, but actually it dates back to the 1st century. Well, I'm here with my dad. I'm happy that he's here, and he's teaching me a lot of stuff that will come in handy in the future. And one of them is what we're going to do to get this sphere rotating over a fire. Something invented by Hero, or Heron, of Alexandria about 2,000 years ago. How are we going to attach that?
We're going to braze it. It's stainless steel to stainless steel brazing, which we'll do later this morning.
Now, when he invented it, it never really gained steam because there was no real work that it did. It was just a novelty. What is brazing? Is it the same thing as soldering?
It's similar to soldering, but it's stronger than soldering. You want to know the difference technically?
No.
Okay.
In this video, we're not going to actually get it to do work. We just want to see it spin.
But anyway, it's like welding or brazing, or they're just different heat points that you use.
So you need more heat to
weld.
To weld stainless steel.
To weld anything, you need more. You need heat. It has to melt something. We use solders, it melts sooner. So it doesn't really, when you solder something, it doesn't really weld it together. You're just using, it's almost like gluing it together.
That's the challenge today, to get it to spin and potentially be able to, with enough torque, turn a rotisserie spit.
When you weld, you're melting the stainless steel ball and the stainless steel rod. You'd be melting all of that together. That's welding.
That's welding.
But we're just going to get something so that it'll like stick it together.
So that's what it's all about. It's turning a chicken over a fire.
And it's good. It could be really strong, but I've never done that with stainless steel brazing. I've always done it with just regular steel.
Originally, Hero of Alexandria had a chamber of water over the fire, brought that to a boil, and the steam went up a couple pipes to the sphere and exited the jets, causing the sphere to rotate. So this one's not true to the original. I guess you could say it's a shortcut. We're trying to eliminate that chamber of boiling water.
But we have special flux and special type of brazing.
Yeah, I bought the I bought the flux, but what's the other stuff that you use? Hero being the genius that he seems to have been.
It looks like solder, but it's a flexible stainless steel piece of rod.
Probably came to the conclusion that the sphere rotated faster if it wasn't filled with water.
It'll melt that has a fairly low melting point, and then it'll stick to but it's not melting this, so it's not as good a stick as if we were welding. So when we have a campfire, can we take some of the energy from that campfire and do useful work with it? So that's the trick. We know it can work. We can make this thing work and spin around, but can it have enough torque, enough force to do useful work?
That's the big question.
That's the big question. So it's an unknown. This is jet propulsion. So when we say this isn't my rocket science, it kind of is.
What is it that you're making?
This is a jig to measure the center of the ball.
The sphere?
Axis, yeah. So we get it square. So I'm going to put two 6-inch legs on it. The ball is 12 inches diameter. 6 inches from this little point right here to the floor. And then when you drop the ball in it, it'll automatically be marked. What I'm trying to do is locate the poles. And we want to make sure that it doesn't wobble when it turns.
It's too hot for me today, but
okay.
Maybe for you. Since you're used to living in Florida.
Is this part of your merch?
No.
No? Okay.
I don't think anybody would want that.
Well, I don't know. And that's where we're going to put our axles in. and then this wheel or ball will turn on those axles.
It says Dr. Chicken Spit. Oh, you look pretty good in that.
Yeah, I feel like going down to the hospital and walking up and down the road.
Yeah, you just need a
down the
stethoscope.
hallways. Yeah. So my thinking is that we really need to get any two spots. It's really critical. Now we got that dotted line. Let's go and see which side we can get both sides to line up.
Yeah.
Does that make sense?
Yeah.
This is called a center punch, and it's got a little point at the end of it. It's this part of the punch is hardened steel, and it's got I don't know if you can see it, but it's got a little point on the top. And a lot of people use like an ice pick or a nail to try to start it, but if you're using metal, it's not very accurate because you have to hold it and hit it. So this was designed so that you didn't have to hit it with a hammer. So it's got a spring inside it, and the tension on the spring, the more tension you put on the spring, the harder the force when it kicks off. So
you adjust the tension by turning it?
Yeah, turning it clockwise or counterclockwise loosens it or tightens it.
Yeah.
See, now it's looser, it'll pop easier. Hear that click?
Mm-hmm.
That click makes a perfect round indentation, where an ice pick makes a very, very tiny hole, and it's not enough to grab the edge of the drill bit. So it tends to wander, even using an ice pick or a nail. So this thing is really hard, and it's a little blunter, so you get a little bigger. I'd say that's about a 1/16 of an inch hole. What I want to do is get this point in the center. So when I drop this will hit right with a dimple that we made with the center punch over there. We made this little dimple right here. So I want this to be right in the middle and it be level, because we don't want to be having it go in on an angle like this. We want it to go straight so it's perpendicular to the very point at the top. Oh, we got everything level. It's level this way. It's level this way. It's level this way. It's level here. So we've got it all leveled up. So what we want to do is find out a point, any point at this point, that's perpendicular to the ball, so that we can find the axis. So we've got a little tool, and I just have to put the pencil in straight, and then I'm going to turn the ball. See that little point that we made with the punch?
Mm-hmm.
It's right there. You can see it, right?
Yeah.
Right there. So what we want to have to do is the pencil, when it comes down straight, it's going to hit the point exactly, like right there. And I can kind of check it visually with the level, but we don't want it shiny where we're going to weld or solder or braze.
You need a rough surface.
Yeah, not a shiny surface, because the solder will just slip right off of it. You have something to grab to.
So that's Windex?
Yeah. We scuffed it off. I cleaned it with Windex, and I think it would be a good idea to run some alcohol, rub a little alcohol on it clean, and not touch that part now with our fingers.
What is it you're putting on there?
Denatured alcohol, because it evaporates really, really quickly, and if there's any fingerprints, oil from our skin or anything like that, we don't want anything to interfere with the brazing. That's good. Yeah, look at the amount of oil that was on there. Some of that was probably marking pencil too. So we didn't want any of that ink to interfere. Yeah, looks good. So we've got the ball wedged in place, and I drilled this hole so it was a little tight. So what I want to do is I don't want David to be trying to hold this rod in place and solder it, where if it moves, it's going to end up being stuck on an angle that's not going to be perfect. So this way we're going to get a perpendicular. This rod is cut really good. It's stock, and it came cut, and it's really flat, and it fits right on that spot really well. And you see there's no air opening, there's no space. If I took a piece of paper, I couldn't get it underneath there. And that's what we want, is a nice tight butt joint. And now I can work on it without worrying about it moving. And that's really important, so we get it all really straight and aligned. So I'm just going to tighten these two screws a little bit. Not much. I don't want to damage it. I don't even want to make an indentation. But now I want it so I could actually turn it upside down if I had to and work on the other side. I'm just going very light pressure. I'm not putting any force on it, because you can imagine if you try to do this with a ball just on the table and it's rolling around, it's hard and it'll roll really good. It's like a ball bearing. So you can imagine trying to drill into a steel ball that's rolling around with one person holding it and holding a rod to that steel ball and having the rod not move nor the ball moved. So what we've done is we've locked the rod in place and we've locked the ball in place. And everything's all level, and so I think we've got it, especially if it's just going to be one axle. If we're going to try to make this work on one axle, I think we're going in the right direction. The only thing I want to do now is I'm going to take it off and do it one more time, and I'm going to rough up the rod. Careful not to touching it with my fingers at the bottom. And it's like sharpening a pencil. I know it's a tricky metal to work with, so anything that we could do to make it easier.
Do you know what the denatured means?
I don't know. It used to be natural and now it's not. It got denatured. No, I don't know what the denatured is. Not much, there's a little bit. There's just a little bit of schmutz on it. There we go. We have landed. So this is test number 1. We're really neophytes at this. Neither one of us has done any welding. David's done some soldering. I've done soldering too, and I've done welding, but I've never tried to braze, especially two dissimilar metals together.
So what do we have here?
So what we've got a little test sample. I've got a piece of just regular mild steel and stainless steel, and we're going to see if we can braze stainless steel together to a regular mild steel plate, and it'll stay together.
So we're going to try that before we do the
this
actual.
is like practice to see, one is we have the skills to do it, and two, if it looks like it's strong, how strong really it is, so we can put it in the vise and hit it with a hammer and see if it's really sturdy. So this is like a metallurgical study test experiment. So what we've got is MAP gas. MAP Pro glass it's called, but it's MAPP gas, and it burns quite a bit hotter than just propane. So in order for this, if we were just soldering with silver solder, we wouldn't need this. We could use propane. But this is like, I think propane is like maybe 500-600 degrees, and this will take it up to maybe 700 or 800. I don't know. When you solder, you're just heating up both pieces of metal, and you're putting a bead around it, and hopefully it sticks. And it does work pretty well, copper to silver. So when you're soldering electrical connections, it's usually a silver contact, and so you use silver solder and it works. But this solder melts at a higher temperature because you need that so it'll bond to the steel. So it's got to get hotter.
And what's that liquid stuff that we have here?
Oh, this is basically just an acid. And what this does is it actually roughs up the surface. It etches. It's an etchings. So it etches it so it'll bond better. What I'm doing is I'm just getting a clean paper towel and I'm just rubbing it around the surfaces. So we want to just get a little flame first.
Oh, I can't even see it.
You can't even see the flame because it's so hot. So we're going to start by just heating it up. I guess when we can touch the brazing material to the surface and then it starts to puddle, that's when it's hot enough. So what's happening right now is it's hot enough, that thin metal plate heated up hot enough, but the rod didn't get hot enough yet. So if I try to get it to stick, it'll stick to the plate. Looks like really well, pretty well, but it won't stick to the rod because it's not hot. The rod isn't hot enough. It's still not sticking as well to the rod. But it's just not sticking to the Well, what happened is the darn stuff stuck like crazy to the metal steel plate, and you can't get it off. I mean, you'd have to use a chisel to get that off. It's a really good bond. Look at how well it bonded, and it isn't even made to bond steel. It's supposed to bond stainless steel. The problem is we've got such a difference in thickness, I think, between this rod and this. So we heated the rod up till it was really, really hot, and we just touched the rod and the solder melted. So theoretically, it should have bonded like this all the way around to the rod, but it didn't. So it stuck. We could move it like this, but as soon as I put any pressure on it at all, it broke right off. So we're going to try another experiment, but it's going to take about 4 hours before we know if it works or not.
And what's this?
And so we've got something called JB Weld, and it's rated at 5,020 pounds per square inch, and a temperature when it's fully cured of 550 degrees. So the way we're mounting it, we think it's not going to be under direct fire. It'll never get over the boiling point of water, which is 212. It might get up to 220, but I don't think so. I think it's going to stay at 212. So it's never going to get close to 500. So we've got a really good safety margin if this works. So what we're going to do is put it together, and then we're going to go work on the pulley system and get that done.
You want to have a flat part on the stick?
Yeah, so that I can apply the stuff like a spatula.
Okay.
And smooth it out. I'll put a little bead of this. I guess it's going to be gray when it's done. So they're equal. I'm going to smush it around in here so I get it on the bottom too. So we get a good thing, and we're going to put it in the vise like we did the others to hold it in place. What I'll do now is I'll turn it up this way so I can spin it around, and I'm going to build up a little.
All right, so plan B is to use that JB Weld. We don't have anything to lose. We might as well use the time, since it takes 4 or 5 hours for the JB Weld to firm up. We're just going to try using it on the sphere now.
Okay, so I'm just going to take a dab. I'm going to raise this up. I'm going to put a dab right on the dimple. Right there. And then I'm going to lower it down, and maybe we don't want it to squeeze all of it out. I don't know.
Yeah, that looks good.
See where I put those marks, the black?
Mm-hmm.
That's sticking up so that the chain won't seat all the way down.
So we're attaching this sprocket to this pulley.
Yes, we're going to attach the socket to the pulley, but the pulley, the diameter of the pulley is just a tiny bit too big.
Okay.
Just on this one side, really, but and so we could make the pulley a little less thick, but it's only about a 32nd of an inch. But I'm afraid that little 32nd of an inch is sticking up. Well, the chain, the roller part of the chain, the chain's got that little roller.
Right.
And it will not allow the chain to roll well.
So now we're going to make the spacers with this aluminum. There's already a hole in the sprocket, but we want to tap some screws into the pulley. So my dad made some punch marks in the center of those holes into the pulley, and now we're just drilling through so we can put the tap in and make the threads.
Yep, it should be easy to make the threads, easier even with this, because the aluminum is really, really soft.
Well, it's a new day, a little bit warm out, and I just finished making the threads for these bolts to go in. So we attached the sprocket to the pulley, and I'm going to add some spacers in there. And my dad is working on the sphere.
One of the things we're doing is we're turning water into steam. It's going to pulse through these vents that we're going to put these jets that we're making. And next step on our list today to do is we've got to have some way of putting water inside it. Since the jets are really small, it would take a long time to inject the water through the jets. So we decided that we needed to have some kind of fill valve, some kind of like a place to fill it up. So we've got a brass nipple and we have a brass cap. So I'm going to cut, it's a little bit over 1/2 inch, and I'm going to use this, what's called a step drill. The drills, so instead of having to have 8 little, 10 little drills and go progressively bigger and bigger and bigger, we can start with a small one and make a much bigger hole just by going step by step by step and be careful not to overdo it. And then when we get close, we'll start fitting it and trying. And I can even measure using a little cheap micrometer to see what size I'm at and what I want to get at. So I can measure the diameter of the hole that we're drilling. And I'm going to use what we've been using all along, our center punch. And I'm pushed till it clicks. And you can see now we've got a really nice little dimple here, so that and hopefully when I start drilling, it's not going to wander all over the place. Well, we're making progress, but it's going to be slow. I moved the ball around so it's at the top. So it gives me 2 advantages. One, I'm just drilling straight down rather than trying to approximate an angle. I'm going straight down. And the second thing is that the water, or not the water, but the lubricating oil that I'm using will stay in the little divot that I've made and help cool it and lubricate it. Okay, so I broke through to that's the first step, as I made a hole. Now this is the first time we've entered the sphere. So that's the very smallest hole. And it took me about, what do you think, about 3 minutes maybe, 2-3 minutes to get that far. Just went another step.
Faster.
Every time I makes a step, it automatically, just by feel, I can tell it went from one level of the staircase to the other.
So it's a lot quicker than you thought it would
It's
be.
much quicker once you get started.
Huh.
Just that first hole took 3 minutes. Now it's maybe 3 or 4 seconds.
Huh.
Incredible. Oh, another step. Wow. Just made 3 steps. Just was 3 seconds.
Wow.
If I just rammed it through and I didn't pay attention, I'd get a big hole here that I couldn't fit anything in, and I'd have to go and find a bigger bushing and a bigger cap to pull in. And this was big enough because we brought a funnel with us. Okay, that's one step. Oh, it's getting really close. I think maybe I got to be really careful because I can almost thread this through. Actually, what it's doing right now is threading it.
Yeah.
And I'm going to tighten this. Before I tighten this all the way down, I think it's perfect. I think we got it perfect.
Yeah.
We're going to get a wrench. And what I'm going to do is clean all this up at the top really good. And I'm going to put a bead around it of JB weld. And then I'm going to screw this down till it's just touching the surface of the sphere, and I'll have a seal that'll make a seal. Another thing that works really good for cleaning is acetone, to taking grease off. This is okay. Alcohol is okay, but I think that the acetone is even better. But it's so yucky to work with. Acetone, it hurts you can burn your fingers with it if it gets on your skin and stuff. So I just picked up a little bit of the JB weld. I'm just going to use this to lock it in place and seal it by putting it on the threads, and it'll have a nice tight, give it 4 hours, it'll be a really nice tight fitting. And slowly tighten it up.
To attach the sprocket to the pulley and provide enough space for the chain so it doesn't interfere with the pulley, we're putting these aluminum spacers in between the holes for the bolt. So I'm just gonna put that on and screw it in place.
This was the top before, and I wanted to take it out so I could move it to drill the holes for the jets, the steam jets. Slow and easy does it. Oh, there we go.
All right, so I have 4 spacers in here, and I'm just tightening these screws.
A little bit nervous. This is just a little bit too small. Maybe just enough to grab. I think the next size would be too big and it'll just flop in, you know? I'll just kind of keep some pressure until I get it started. Yeah, it's grabbing good.
Nice. All right, so take this screw glue, dip some on the thread, and stick it in the hole. I think I put too much on.
It's okay. It doesn't really hurt anything.
So now what we're going to do is get the bearings in place on the EMT. So the sphere I'll have these 2 bars fairly close together with a couple bearings. So this little bearing is going to attach to the EMT, but we want a flat surface to bolt this onto. And normally in the past what I've done is put a block of steel under it and just hammer it flat. But my dad suggested a really good idea to stick the EMT in a vise and try to flatten it, so then we'll get a flat edge on both sides. We don't have to compress it completely, which would weaken the strength of this, just enough to get a flat surface. So we're going to try that. So the middle of this EMT will be 27 1/4. So we might need a pipe for leverage, but I'm pretty sure you're right that we will.
Because I don't think just by your hand with that angle you'll be able to get enough leverage. The thing I like about it is it's even and you don't have any hammer marks on it.
Yeah, and it maintains the strength of it too.
Yeah.
So now I'm going to make this opening larger with this step bit, I guess it's called. Oh, that's cool. You can hear it click. I might want to make that even bigger. All right, so what have you been working on, Dad?
Well, I've got these 2 fittings for the jets. One on this side and one on the bottom.
Okay.
And I've got them tapped in as best I can. There's some mechanical connection there. Not super strong, but I think it's going to be good enough. And then I put the JB weld to reinforce it around it. And so what we want to do is connect the jets. And the way we do that is we take this nut thing, and it's got a ferrule inside. It's got a little.
So this is some kind of brass connector that we bought at Lowe's or wherever.
Yeah, it's used for connecting water hose to your refrigerator, kind of a thing.
Okay.
So what we do is we slide the nut, the compression nut on, and it's got this. Let's see it. It's like a little barrel thing in the side.
So this is a piece of 1/4-inch copper.
Right.
And a 1/4-inch.
Yeah, they call it a union. Quarter by quarter.
Okay.
So what we're going to do is put this sleeve, or I think it's called a ferrule, that you put it inside the copper. So that keeps the copper, when it gets crimped, it keeps the copper from collapsing. And then to tighten it, you just push it in. It mates with that little ridge, and as you tighten it down tighter, it's going to squeeze it and make a watertight connection, hopefully steam-tight connection. Probably have to tighten it with 2 wrenches, one to hold this from not moving at all so it doesn't break.
And what's this gray stuff in here?
Oh, I took some of the JB weld because we don't have any nozzles for it. I mean, to change the diameter out. And the smaller the nozzle, the higher the force of the steam coming through it. And so we don't know, this might be too big if it was just the open pipe, 1/4-inch pipe. So we wanted to start with a very small hole and work up and see which worked the best.
So we'll make a pinhole with a drill.
Well, drill, we just have to, this has only got the JB weld into about right here. It's right at the beginning of it.
About a 1/2 inch.
Yeah. So we just take a drill and drill it through it and then try it. And then if we think we need to get more steam coming out, we can drill a little bit bigger. And if we go too far, we can just stick some more JB weld in. So
Yeah.
we've got it just as a time lag between the dries.
Yeah.
So it's not instant, you know. The smaller the nozzle, the more pressure there'll be built up in there, and then the faster it'll turn. And it's already turning at, the models we've seen on YouTube are turning at 2,000 RPMs to 3,000. Maybe with a small nozzle, it'll turn at 5,000 RPMs. It'll be like a race car, and we don't want that. We want a turtle, not a rabbit. The smaller the nozzle, the higher the force. Because imagine if you had the nozzle this big, with all the steam, it would come out in a few seconds, and it wouldn't really do much. So what we want to do is narrow it down to what's called a venturi, to a small opening, and we don't know exactly what size. We're going to start it drilling it. So I plugged this up with some of that epoxy that we've been using.
JB Weld.
JB Weld, it's high temperature epoxy, which is rated for 550 degrees, I think, or something like that. And we know that the boiling point that turns water into steam is 212 degrees Fahrenheit. So the epoxy is not going to overheat and drip out, because if it does what it says it's going to do, it will hold up to 500. And this will never get up to 500, even with the fire above it and stuff. It's never going to, I don't think, ever get above 500. It didn't click because I can't push that hard.
So we have a 1/16 inch hole.
Yeah, and we're going to do 2 of them, which will be a total of 1/8 of an inch hole, equivalent to 1/8 of an inch hole.
I've got the bearing on now, and a washer and a nut, but the screw is too long and we don't want that to cause interference with the rod, so we're going to take the grinder and knock these off instead of going out and buying new screws.
For the first phase, we're ready now this is completion of the first phase. We've got the actual Hero engine built and ready to be mounted into its stand. So this is a milestone in this. A lot of work, but it was fun doing it. Okay.
And I can always raise these because I have some flexibility there.
Okay. Yeah, well, that's great. And we've got 2 inches of clearance here.
I'm just going to tighten these.
And boy, it seems to spin very nicely, right? Look at that.
Yeah.
Oh yeah, it wobbles a little bit. It's wobbling just a little bit.
My dad is leaving today, and we really wanted to do a trial run with this. But as I was adjusting the rack here to hold the sphere, guess what happened? Just a little bit of movement and this rod fell right off. So the JB Weld alone is not enough to hold the sphere. All right, we came up with plan C, and that is using a hollow rod. This was actually a straw that I used this morning, one of my wife's stainless steel hollow straws, and it just happens to be 8 millimeters thick. So it fits right through the bearing. It's the perfect size, and we're thinking that because it's hollow, rather than using a solid steel rod, since it's hollow, it might be easier to braze.
No.
So for some reason, the brazing rod material is just beating right down. It's not sticking to the stainless steel.
It's stuck, but not very well. Look, what happened here? Feel that.
Do you think we're getting the solder too hot? Are we getting the surface too hot? Maybe we don't need to get it that hot.
Maybe not. Maybe you just try doing a little heat. Yeah, because what happened is, you're right. where it was cooler, it stuck. And when it was too far away, it wouldn't stick at all. And it stuck a little bit, and then it stuck at one spot. I mean, something happening here.
Yes. It either has to do with the temperature or the flux, or both.
I think it's both. I think I'm heating it way too hot. Just heat it up a little bit and then touch it and see what happens. A little bit and touch it and see what happens.
Because those are stuck on it. We can't get those off hitting it with a screwdriver. They're stuck on there.
Yeah,
we'll have to grind them off.
We can grind them off or hit it with a little hammer or tap and see if it comes off. But it's holding good. It does work. Something's working, but
it's just our technique.
Yeah, it's a technique. I think it's us, not the material.
Yeah.
Oh yeah. Oh yeah. Oh yeah. Okay, wait a minute. Yes. Look at that. Oh, I have the smell of possibility.
Oh. Too hot when it gets like that.
Yeah. Okay. Let it cool a little bit. I'm gonna have to flip it around to get it to the other side. I don't know if it'll work, but it looks good. And that was it. We were just overheating the heck out of it because we had to heat. We had to get the. It's so tricky because the ball would cool off so much faster than the rod would.
Right.
We had two dissimilar thicknesses, made it almost impossible to apply the solder.
Yeah.
Oh, I am getting excited. Yep. Yep. Oh, this is so cool. The secret is putting plenty of flux on, not making it too hot, putting only a little bit on, and making sure it sticks. And if it melts too much, take the heat away. It doesn't melt enough, put a little bit of heat, but just a couple seconds of heat's enough to melt this solder.
And there's the connection. That looks pretty nice.
It's really clean looking.
All right, so we have the sphere on the rack now, attached to the sprocket. It spins freely, but there is a little bit of a wobble, probably because of this spigot here. There's a little extra weight on this side, and like Dad said, just like a wheel, we want to balance it as best as possible. I want to get some tire balancing weights, but we don't want to spend the time going to the store now since Dad's leaving in 2 hours. So we're going to try and put some coins, just tape some quarters and pennies or whatever over here and see if we can eliminate some of that wobble before we go for the test run.
We don't want to put too much water in here because we want to see what happens as the steam comes out. If we could actually get even to turn for a couple of 15 or 20 seconds would be a good start for the first test. So if we put a whole lot of water in and something goes bad, it's going to be hard to get the thing to stop. And I don't want to get near it. And so we put a safety rope on here, and you can see I put the setup down here with a piece of metal heat shield so that we can heat it up without me standing right next to the thing and heating it up. Until we see what happens, we don't want to get too close to this. So as a safety precaution, like they say, try this at home. This is for entertainment purposes only. And so this is our jury rigged, probably not OSHA approved setup, but we're going to heat that up. We can stand over there and sit in a chair in the shade and watch it happen. And we're going to put four cups or 16 ounces in. So I'm going to fill it up now. Not filling it up, I'm going to put it in now.
And if we want to remove it from the fire, we have this rope. We can just pull the box. The propane is secure in there, and the rope is over there. We also have a hose ready if we need.
Cool it down in a hurry.
Yeah.
So I got the cap. I can turn it so I can. And I'm not even going to I don't want to put this cap on all that tight either. I'll just put it on just finger tight. Don't put a wrench on it or anything. Turn the gas on. On a bright sunny day like that, you can't see the flame. So you can hear it, but you can't see it.
You have any popcorn?